In our last class, we discussed some terminologies that are used when discussing mapping or function. So your understanding of those terms will help you a lot to understand what we are about to discuss in this lesson. So in this lesson, we shall be looking at types of mapping or function. So mapping and function are of different types. So we want to look at some of the types. So in this presentation, I will be discussing about 6 different types of mapping. So let's see. So the very first one is what is known and called one-to-one or injective mapping or function. So if you don't want to call it one-to-one, you can call it what? Injective. So when do we say a given mapping or function is one-to-one or is injective? Let's see. This is a mapping that is such that distinct elements in the domain, that is in the inputs, are assigned to distinct elements in the co-domain, that is the outputs. Hence, in an injective function, neither one-to-many nor many-to-one exists. What do we mean by this? To understand this better, let me give an example, that is a pictorial illustration to explain what this is all about. So look at this mapping, the association between set A and B represented in this diagram. So let's use it to explain what is meant by one-to-one. So we said one-to-one is a mapping that is such that distinct elements, so take note of that, distinct elements in the domain is assigned to distinct elements in the co-domain. So take note of that. So that's why we call it what? One-to-one. So what that simply means is that all elements in the domain, each one is assigned to another element. There is no sharing, either from input to output or output to what? To input. No sharing of elements. Look at this. This 1, which is our pre-image in the domain, is assigned to 5 and not any other element in this codomain is assigned to 1. So this input maps this output, and this output is also associated with this input. So the same thing applies to 2. 2 maps 8, then 3 maps what? 6. So in this case now, it is always one-to-one. We cannot have one-to-many. That is, we cannot have one element in the input that is going to map with more than one element in the output, and we cannot have one element in the output that is associated with more than one element in the what? In the input. That's why we have said that in the case of one-to-one mapping, neither one-to-many nor many-to-one exists. It is always one image with one pre-image, or one input to its own output. No sharing of input, no sharing of output. When we have this kind of situation, we describe it as one-to-one, or you can call it what? Injective mapping. So with this, there is one thing to note in this example that I've given. Note that all elements in codomain need not be images to elements in the domain. So what that simply means is that it is sufficient once you have a mapping where there is only one output to one input, that is, the input and output are one-on-one, no sharing. Even if there are extra elements in the codomain that are not assigned to any element in the domain, that does not stop it from being a what? A one-to-one or injective mapping. So we simply means this 7, even though it's not associated with any element in what? In A, then it doesn't mean this whole mapping is not one-to-one. It is still one-to-one. What we watch out for is each element in the inputs should associate with one and only one element in the outputs. And that is just that about one-to-one. So let's look at another type. That is what we call onto. That is what we call onto mapping, or we may say subjective mapping or function, as the case may be. What do we mean by this? Let's see. This is a mapping that is such that every element in the codomain, that is the output, is an image of at least one element of the domain, that is the input. So what do we mean by this definition? Let's explain with a diagram. So look at this arrow diagram now. This is an example of onto mapping. What makes it onto? What you just watch out for is that if you want to know whether a mapping is onto or not, just go to the codomain. These are codomain, that is elements of the output, D, E, and F. So for it to be onto, each element of that codomain must have an image in the domain. We must not have an element that just stand in the codomain without associating with an element in the domain. So look at this fourth example here. This mapping can never be onto. Why? Because we have 7, which is an element in the codomain, but it is not associated with element in the domain. So it is because of this element 7 in the codomain that is not associated at all. That is what disqualifies this very mapping to be called what? Onto. But unlike here, each of the elements in the codomain must have an association with elements in the what? In the domain. It doesn't matter if it shares more than one element in the domain. But all we just know is that we must not have any element in the codomain without having at least an association. That's why we mention in our definition here that at least an image. What is it? It's such that every element in the codomain is an image of at least one. That's what we mean by that. At least one element. At least one element. At least one element. So that is what we mean by that. So this is what makes a mapping to be called what? An onto, or we may say a subjective mapping or function. By now you should know how to distinguish between a mapping or function and when to use either of the two terminologies. Now let's move to another one. Like I said, you should note, this is very important. Know that an image may have more than one pre-image. So as you can see in this example that I've given under onto, you can see that this E, which is an image to both A and at the same time to what? To C. That doesn't disqualify this to be an onto. That's why we mentioned that phrase, that at least one element. It may be more than that, but what is most important is that we must not have an idle element in the codomain that is not an image. So that is just that about that. So the next one now, we have what we call bijective mapping. So as the name implies, what do we mean by bijective? This is a mapping that is both onto and one-to-one at the same time. That is, when we say a mapping is bijective, it simply means it shares both property of one-to-one and onto at the same time. So when a mapping is one-to-one and that mapping is also what? Onto, then we say that mapping is an example of what? Of bijective. So let's look at an example of that. So this is a bijective mapping. So let us analyze it. Is it one-to-one? Yes. Why is it one-to-one? Because one input to one unique or distinct what? Output. No sharing of input, no sharing of output. Look at it. A has 4 and no one is sharing 4 with A and no one is sharing A with 4. So D has 3. The same thing, C has 1. 1 is not shared by any other element apart from C, and C is not shared by any other element apart from 1. So with this, we say this is what? One-to-one. This is what makes it one-to-one. Now, what makes it onto? It is onto because all the elements in the codomain they have an association with at least one element in the what, in the domain. So there is no element here in the codomain that is just standing alone without being associated with the what, with the domain. That is what makes it what, onto. So this very mapping is both onto and one-to-one at the same time. So we say it's an example of what, of bijective mapping. So let's move on. Then we have another one, we call it what, into. So when we talk about into, what do we mean by that? This is a mapping that has one or more elements in its codomain that are not associated with elements in the domain. So what does that mean? It simply means if a given mapping does not satisfy the condition of onto, in most cases it will be a kind of a into mapping. What do we mean by that? If you look at this first example that I gave here, what this very first example, it can never be called onto. Why? Because we have 7. This 7 is an element of the codomain, but it is not associated with any element in the what, in the domain. When you have this kind of situation, because of this 7 that is not associated, it may be one element or more than one. So but once you have an element in the codomain that is not associated, that is just standing, no association with element in the what, in the domain, then that kind of mapping is said to be an into mapping, which simply means this example that I've given as one-to-one can also be said to be what, to be into mapping. So it is one, in this case now, an into mapping. We can give an example. So you can see this example now is just this very first example of one-to-one, but here we call it into, not because each one output for one input. No, it is into because we can see an element in the output that is not associated with any element in the what, in the input. So that is what makes it what, into. In other words, it simply means an into mapping is a mapping whose codomain is greater than its range. What is our codomain here? 5, 6, 7, and 8. But our range is what? 5, 6, 7, 5, 6, 8. 7 is left out of the range. So when you have an element like that that is left out, despite the fact that it belongs to the codomain, but it does not belong to the range because it is not associated with any element in the domain, then that mapping becomes what we call an into mapping. So that is just that about into. Then the next one is what we call an identity mapping. So when do we say a mapping is what? Is an identity mapping. This is a mapping whose pre-image is an image of itself. That is, an input produces itself as output. So let's look at the diagram to explain that. So this is an example of identity mapping. Why? Because whatever input you have, that input itself will produce itself as an output. So a very typical example of this kind of function that is very common is power of 1. When a function is guided by a rule as power of 1, let's take 3. So if you say 3 raised power 1, your answer will still be 3. If you say 4 raised power 1, your answer will still be 4. So for every element in the input is going to produce the same element in the what, in the output. When you have that kind of situation, you can see B is input, B is output, C is input, C is output, A is input, A is output. When you have this kind of scenario, we call it what? An identity mapping. So you can see that all this classification may be intertwined. This mapping now, I can say it is identity mapping because each element in the input produce itself as the what? The output. And I can as well say this very mapping, this example is also one-to-one. Why? Because each element in the input has its own outputs on its own. No sharing of input, no sharing of output. So it is one-to-one. Then I can say it is also onto. Why? Because all elements in the codomain, they have at least one element as their pre-image in the domain. So you can see these things can be intertwined. But just know why which is classified as which. That is, why are we saying it is one-to-one? Why are we saying it is onto? You must be able to clarify all this. So let's move on. Then The next one we have is what we call a constant mapping. When do we say a mapping is what is constant? This is a mapping that is such that all elements in the domain have one and same image in the co-domain. So look at that. So when you have all elements in your domain are having just one and same image, then we say that element, that mapping is a what? A constant mapping. So when they have same image, same image. An example of this is if a function, if you have a function that is guided by a rule, power of 0, you can see that if you say power of 0 is the rule here now, a raised power 0 will be what? 1, b raised power 0 is 1, c raised power 0 is 1. Bring any element. When you take the power, the answer is always what? 1. So the resulting mapping is called a what? A constant mapping, because all the elements in the domain, they are having one and same image in the codomain, and that is what makes it a constant mapping. So these are the different types of mapping that you can come across. When you are given a function, you must be able to analyze which class or which type of a mapping is it, or function, as the case may be. So I'm using the word mapping and function interchangeably, even though in our previous lesson I have explained the clear difference between the two, and I believe you can always distinguish when it is important for you to distinguish between the two. So if you have any question, you can always contact me. So these are the types of mapping. Thank you very much.